Okay, so we're still kind of in the early stages of interpreting things without actually, computing anything. I almost said computating, or whatever. Let f of t be the amount of rain in inches that has fallen since midnight, where t is the time in hours since midnight, and in a complete sentence including units, interpret the following. All right, so let's draw our little first quadrant sketch of our graph, our axes. We got f of t, which is going to be inches of rain since midnight, and t is going to be an hour since midnight. So we know immediately that the derivative is going to have units of what? Inches per hour. Good. Units of y over units of x. Okay, sweet. So f of 10 equals 3.1. That is the instantaneous position or amount of rain. So we would say, again, you could just say at t equals 10 hours. That would be kind of the real generic way to do it. But you could also say what in this case? Yeah, at 10 hours past midnight. Past midnight. That's a little bit more writing. That would work. Or in this case, you could even say, because we know how clocks work, right? You could say at 10 a.m. Either one of those work, right? I would kind of, in general, remember just tell you to do the first one, at t equals 10 hours. Boom. But any one of those would work, comma, what would we say? Right, or just 3.1 inches of rain. What, have had? Has fallen will work, yeah, has fallen. Good. So by 10 a.m., 3.1 inches of rain has fallen, okay? Something like that, instantaneous amount. But no, you are absolutely correct. Later, using the words up here, the amount of rain in inches that has fallen is 3.1. Good, inches. So make sure that you have your units on there. When you put AM, that stands in for units instead of hours, right? But you have them on your independent variable and your dependent variable. All right. Is that the derivative? No. I don't miscopy like that. That is the actual what? Inverse, right? So how do we get an inverse? What do we do with x and y? Switch them around. Yeah, very good. So let's go ahead and draw another one of these fellas. And this time everything is switched around. So F inverse now is going to be measuring time in hours past midnight against our independent variable of rain that has fallen in inches. So for what it's worth, F inverse prime, this is how you would write it. That would be the derivative of inverse, would be measured in what units? Hours per inch. Yeah, very good. If we should need that. Okay, so this then, the 10 stands for what? Inches. So when 10 inches of rain have had fallen, or how about has fallen, comma, what are the units on 16? Hours. 16 hours have what? Has elapsed? Is that okay? Or passed, right? Has passed. 16 hours has passed. Yeah. All right. So that kind of makes sense, right? When 10 inches of rain have fallen, 16 hours has passed. That'd be like the person that's outside watching the rain gauge and then looking at, whoa, that's amazing. We've got a lot of rain. And then you go look at the clock, right? Okay. This one, we're back to f prime of 8 equals 0.4. So f prime comes back up here. Our independent variable, again, is now hours, and our units are inches per rain, or inches per hour, sorry. So this 8 represents what? Time. So you'll say at t equals 8 hours, or at 8 a.m., comma. The amount of rain is 0.4. Is that what we say? No. The amount of rain falling is whatting? increasing. The amount of rain that's falling is increasing. You could say at a rate of or just by. That's a little bit shorter. By 0.4 centimeters, or inches, inches. And we write that out per hour. Again, because we're giving it in units of amount of rain, so we have to use units there. And then we write each hour or every hour. Question, Benegoni? Oh, you're stretching? Okay, cool. Anyone else want to stretch right now? I won't call on you. Stretch break. Yeah, there you go. Oh, that feels good. I'll step back. Okay, sweet. Any questions on that? It's picking up, right? It's picking up. At 8 a.m., it's picking up. Last one. F inverse prime of 5 equals 2. Go for that one on your own. This one's going to feel weird. Oh, sorry. Did y'all finish? Okay, so it's F inverse prime. So this 5 represents what? Inches. So when 5 inches of rain has fallen, comma, what is F inverse measuring on the y-axis? Time, right? So we would say time is what? Increasing or decreasing? Time is increasing. That kind of sounds weird. What's a better way to say it? Time is passing. Time is passing at a rate of 2 hours per inch. When 5 inches of rain has fallen, time is passing at a rate of 2 hours per inch. This is very backwards from how we usually do things, right? We usually let time be the independent variable because time is the ultimate independent variable, waits for no man. We kind of see how much time has elapsed and then check the rain gauge. This is kind of backwards. I mean, it works theoretically, but it would be like this guy who on his wrist, instead of a watch, has a what? Yeah, he has a rain gauge. That's supposed to be a rain gauge. And he's just collecting water on his wrist, and he's using that as his clock. So as soon as he gets 5 inches of rain up there, he's using that to determine how fast time passes instead of the other way around. So kind of interesting. I mean, you can work, right? But it's not typically what we have. Now, maybe there's an app for that, right? Does the Apple Watch, does it have a rain gauge on it? Wouldn't that be cool if it did? And it just recorded like the magnitude, the how the drops hit the watch. Like, ooh, that must have been a big fat piece of rain. Oh, that was a light drizzle. And then using the surface area, kind of calculated the amount of rain. That would be pretty cool. But until then, you're just left with walking around with an actual graduated cylinder on your wrist. Okay? Right. Anyway, it's a good place to stop, right, for lunch. My Art 1 teacher would be proud of me drawing that right there. Okay. It's not like Joey Boykin good, but it's decent.